Right, well, welcome. This is the first of the AI speaker series that we'll be doing mostly this semester. There may be a couple that go into the fall, but we have right now two scheduled speakers, Saurabh Mishra today and Minghui Huang on March the 30th. And then we have three other very good speakers who have accepted but are not yet scheduled. So once we get them scheduled, then we'll let everybody know about that. So here's how we're going to run this session. First of all, I'm going to introduce our speaker. Then he's going to give his talk. Then we'll have Q&A that's specific to Saurabh's talk. And then we'll see what the time looks like. If we have time, I may have some formal comments as well, but I don't need to. And then we'll have general Q&A about AI. And some of the questions that have come in prior to this session were of the more general type. So we'll be able to address those as well. So first of all, I'd just like to introduce Saurabh Mishra. He is the CEO and founder of Taiyou, which is a company that is really addressing how to use AI for physical infrastructure, which we usually think about AI as being more like an information service. But he's talking about using AI for some of the biggest, heaviest physical industries that are out there. And he has worked for the World Bank and the IMF. In fact, that's the reason that we're fortunate enough to have him visit us today is that he's in town to visit the IMF. And so that's where he was. And but I should also mention that Saurabh is a proud Terp. He's a PhD graduate from the University of Maryland from the engineering school. And I was fortunate enough to serve on his dissertation committee when he got his PhD. So I'd like to ask Saurabh Mishra to come up. Thanks.
Oh, you can hear me fine? Yeah. Well, Roland, thank you for that kind introduction. And so feels like being home again, back on campus. So it's been almost a decade for me to be back here. So it's good. City has changed, the world has changed, but we're still here. As Roland sort of kindly pointed out, my background, so I spent many years, over a decade in Washington, D.C., with the World Bank, IMF, IFC, leading many large engineering projects in developing countries. And I was very passionate to solve, been working on AI and economics topics for almost 2 decades now. And Maryland was very exciting to me because it's a engineering powerhouse, highly multidisciplinary. When you're in a place, you want to get out. But now when you look back, it was the best intellectual times being on campus, open mind, learning, new things. And I was fortunate to be at the Clark School of Engineering, where I ended up sort of probably writing one of the first theses on AI and mega project management. And I then went to Stanford at the Institute for Human-Centered AI, was the director of the Stanford AI Index. Great initiative because, AI is a very data-driven field, but data about AI remains very hard to come by even today. So I think it's very important that we ground the conversation in AI in data. And that's why this initiative came about. Ended up teaching at Berkeley and different universities in the East Coast and Europe. And as Roland pointed out, I noticed this challenge in the world's largest industry, infrastructure, construction, government contracting, and noticed that there's a white space where AI and intelligence, right, is not being brought to such a consequential industry. So with sort of that diverse background, I'm happy to be here with old friends and colleagues on campus, and excited to share some of my thoughts on this topic. I hope this is helpful from a educational point of view for the students who are online and here, but also some faculty. There might be opportunities to expand research on this as well. So thank you, Roland. Thank you, Dean, for having me. Let's have a conversation rather than me just talking, and feel free to chime in as you see fit. So I feel, a lot of this talk is about equally not just AI, but how do we bring back critical thinking, much needed, right, in this increasingly uncertain world. So what I'm thinking about as a conversation this evening's journey is one, just to set the stage up to talk a little bit about how I see the role of AI in the global economy. Roland and I's work has been deeply rooted in the service transformation. So we'll touch upon that. Introduce this idea of what I've been calling cognitive infrastructure. And then give you specific use case for this massive industry in construction, infrastructure, and government contracting. Hope I can show you a demo. Some ideas of actually how the UMD community, both students, faculty, can all engage. Some ideas, and look forward to having a more in-depth conversation with you all. But before we begin, I'd like to wake up the students who are on Zoom and everyone here a bit and ask you, when do you think AI emerged actually as a field, and what were the founding values? That's why you should not have Dean in the house, because he'll answer the question right away. But you missed it by 2 years.
1956.
You missed it by 4 years, actually.
Oh, no.
Oh, you actually should. I was wrong. I thought it was 1952. So actually, Roland got it right. Yes, of course, it was the Dartmouth conference. And what excited me about the field was that it's highly multidisciplinary. The initial grounding of the field of AI came about to mimic the human brain, as we know. One could argue that the current wave of AI and waves of AI have diverged from that original view, but I think that was exciting of sort of how this field really came about, a highly multidisciplinary, and really inspired by cognitive sciences and the brain. But maybe a slightly more complicated question to follow up on that. In evolutionary biology terms, when would you think that language emerged? Say?
I don't know what's the specific, maybe 5,000 years.
Language?
Again, I don't.
In evolutionary biology terms, but I guess language is a construct by Homo sapiens, so something to that effect. Yeah, I mean, thousands of years, and recent research came out even last week that, but I mean, it's definitely not, people say it's like maybe even 100, 200,000 years, but maybe 500,000 if you're really but like stretching it, fine. But the real question is, when do you think vision or the perception of the real world as we see it emerged in evolutionary biology terms?
Very early.
Huh?
Very early, millions of years ago.
How many? Just like guess.
Many, many millions. 200, 300, 500, a billion maybe.
500 million years or so. Yeah, slightly maybe. Yeah. But that's an interesting contract, because we live in a world so dominated by language models. But if you were looking at mimicking the human brain and evolutionary biology terms, the perception of the physical world emerged at least 500x much, much earlier. So I don't know, my point being that maybe we're not exactly following the trajectory of evolutionary sciences as AI becomes more and more powerful. So I'm going to just help structure this conversation by giving you some facts and stylized facts, if you may, about. Please go ahead. Yes. Yes. Yes.
We didn't take before language, etc., was human, I guess, existential response to this living life, right? does AI have the same requirement? And if it was left to evolve, would it have developed certain senses ahead of the others? Like, we saw first because we had to see, otherwise we would die, right? And so a lot of the human senses and the sequence in which we built them came as an existential response. Now, AI is built by us.
Yeah.
And in that sense, it doesn't have the same
Yeah.
history. So when you're trying to think of
Yeah.
two, is there an angle that you were going that would make sense to think of? Like, there's a lot of
Oh, absolutely. And maybe those existentialist risks are no longer existentialist, but actually here and right now. Your name, sir? Balaji. Thank you. That's a phenomenal question. And I think different people might have different opinions. But I think there's also, you see, classic great AI scientists who invented the field involved in the last few decades would, again, tend to argue, I think, right, that it was all about self-learning, right? You leave an agent in its space and figure out about mistakes it's doing, as humans do, to avoid those mistakes and learn better, right? To self-evolve. Some of those capabilities do exist, but I think that's exactly also the limits, what we're trying to push the frontier, right? So one limit for current state of AI or language models specifically, right, is a understanding of the physical world as is. Another might be that of uncertainty, of not exposing, right, to the end user what it does not really know, right, as well. And I think there is, especially in the last couple of weeks, with more autonomous agents with OpenClaw and different coding agents with Cloud and Anthropic, there are elements of that, but I don't think quite. If developers are not going to keep constantly tweaking these models, these things will end up having wear out. And the current evolution is highly dependent, exactly as you said, of humans actually tweaking these systems, at least today, I think.
No, and I think we are building sensors into modern AI, like the sensors we have, right? That's
right.
Language, vision. We're thinking as humans.
But it needs.
They're giving it the sensory.
But you see, these are billions of dollars of investment in compute infrastructure, billions of dollars in data engineering, billions of dollars in new models. Models are kind of also hitting a glass ceiling with transformers. But it requires developer engineering, human intervention to advance the current state of the model on a weekly, daily basis. It's not that they are right? And that's kind of different from the early days of what the vision for AI was.
Can I ask a question?
Please.
Sorry.
This is great. This is more interesting.
There are now movies where you're building AR, jealousy, things that are very unique to human.
Yes.
Animals don't have greed, lust, greed. Even when your stomach is full, you want to kill others for benefiting. And you start to see movies coming out where you're building these things into the model and they go rogue.
Yeah.
And you don't know how to control.
Totally.
So you see that in English movies and in Bollywood movies are also coming up with bizarre AI agents, pretty much like human beings can be corrected somehow.
Mm-hmm.
But AI, when they go rogue, you can't correct it unless you pull the wire.
Well, you put the human in jail, or you put the human.
So AI, when they go rogue, then it goes wrong.
We just saw examples, right, of where OpenClaw and other such things last week, right? You give access to your emails, and it just deleted your historic emails autonomously on its own. It deleted developers' databases, right? So one has to be extremely careful with again, but we're still different.
Power-based, racism, other things.
But how much of that is actually from inception, how you're training the model and actually designing the system, right? So it's a human who's designing the system. We'll talk a little bit more about those aspects, actually, of reliability, safety, a little bit. But I think that the point here is that someone designed the system without guardrails to behave in that manner. But you can design it to, that's an important, I think it's an important frontier, but people are building system without guardrails and thinking about the downstream consequences. So that's why regulation policy, AI policy becomes very important, but the pace of development is so fast and policymakers are reactive rather than proactive. So again, my 2 cents on this topic is that the only way to solve these issues is through AI itself, is to build safeguard, like it's actually AI will help solve AI's problems because humans just can't keep up. Even the smartest humans cannot keep up with the pace of change. But these are exactly, I think, the important questions we should be asking. I'm not saying I have the answers either. So
I also had a question.
yes.
Say that the vision seems to be completely shifted from what I guess the inception of the concept of AI was in the 50s. You know, I'm uneducated on this, whether the billions of dollars that are being put into this research are even being put into the possibility to maybe build models that can replicate, I guess, the vision aspect of the human brain, or is it just not maybe profitable to do so? Maybe it just makes more sense to build models that just focus on the language aspect that can, I guess, optimize, I guess, processes and stuff like that.
What's your name?
Axel.
Axel, that's actually a very educated question. So give yourself credit for that. It's a very educated question. Actually, I think efforts are being made, and I will show you some examples from my small point of view. But yes, I think there's actually billions of dollars being spent, not just at OpenAI, Anthropic, and Grok, but other companies, which are totally about some of these concepts. But we could get into the discussion aspect of, I don't know, I think OpenAI is going to have going through $110 billion in the next 4 years. There's some political will where we're spending probably about $1 trillion globally on data centers. That means that this big tech 6, 7 companies, right? There's amortization and depreciation of capital expenditures where they're just funneling money between each other to get off the hook on balance sheets, maybe a little bit like Enron, some could argue. You're too young to remember that case, but there are limits, right? By just throwing more compute power with the same model architecture and even just throwing more data is not going to get you the next frontier. All I'm trying to say is that it's a very nuanced discussion. There's no black or white, but efforts are people recognize these limits, I think, and efforts are being made on some of these fronts.
Thank you.
All right, let's get to some of these data trends. A couple of facts to just like help set the stage here. Something Roland and I have spent almost a lifetime working on. But what's interesting is, this fetish with manufacturing-led growth around the world. But with the left chart, it's a little complicated. It's not causality, but just some correlation. If you looked at each dot is a country, and on the x-axis is the growth in sectors of agriculture, industry, and services. And on the y-axis is the per capita GDP growth of countries. And what we see unanimously, right, is that per unit of economic growth, right, in services leads to higher economic growth for countries. Again, I'm not trying to claim causality, but this is a factoid that services drive economic growth. Whereas on the other side, on the right hand, you see the share of world trade in goods has been declining, and what's actually increasing is the world trade in services. The reason I'm trying to impress this upon you, because AI at the end of the day is a service. And this fetish, I didn't add quotes from latest presidents and prime ministers out of being apolitical, but I think a root cause for a lot of this goes back 250 years from Mr. Adam Smith, who questioned the value of service providers, I think present company included, lawyers, physicians, buffoons, opera singers. Like, they don't add value to the economy. They're not tradable. I think we all love William Baumol's work on services, but there's this sense of, services don't end up leading to more productive capacity. So if you look at CEOs to prime ministers and presidents around the world, you will constantly keep hearing this bias against building intangibles. But honestly, that's the real economy. And I'll make a case that so is AI, just a service, which is powering the rest of the economy. So what we'd like to call the first service revolution, right? It took place around the early 2000s. And what it did, it led to the tradability of services for the first time in the history of humanity. What you have on the left side is the growth of service exports, which is measured through IMF balance of payments. And what's interesting is that you see that developing countries have a much higher, starting from a smaller base, but grow much faster in the export of services. But there are two types of services, right? There are traditional services. So, well, I guess it's debatable if teaching and professors are a traditional or modern service, because we can be talking on Zoom and people can still deliver it. But if you're going to get a haircut or go to a restaurant, you have to be face to face. But what happened around the 2000s, what you see is countries like Philippines, India, call centers, back office services really took off. And that created a contrarian model of growth to what we know about China's manufacturing-led growth, to an alternative model of growth and development. So the chart at the bottom left shows that the export of modern services, these tradable services, it's growing significantly faster from developing countries than advanced economies. People would argue, hey, but how about manufacturing? Even the full value chain of manufacturing, as the chart on the right shows, the high value added components are in the service activities, right? From the early stages of R&D, the middle of the life cycle, to marketing, advertising, logistics, branding, and more. So the point being that services are through the life cycle of not just end-to-end service production delivery, but even the higher value added components of manufacturing. So this was really the first service revolution that led to, from outsourcing labor to tradability of services. But what's happening, as Roland and I have been a proponent of, we'd call this the second service revolution. That's taking place as we speak now, because tradability of service already happened in the early 2000s. What we're talking about now is outsourcing cognition. And if you look at production, delivery, and consumption of service lifecycle, a lot of what AI is impacting is the production part of services. So the first service revolution led to tradability of services. What the second service revolution is doing is impacting directly the production of service activities. Other aspects too. Fact two, the cost of intelligence is collapsing. So on the left, you have training AI models. You'll see GPT-4 all the way on the top, or I think 5 and so forth. But nobody exactly knows how much it took to train these models, but easy and safe to say over $100 million to train, just the compute access. Some caveats to what I'm going to say next, but if you looked at the reduction in costs, right, from DeepSeek R1, T1, S1, these 3 dots here, within a span of 2.5 weeks in February of last year, the cost of that $100 million plus to reach higher performance within 2.5 weeks, went from $12 million to, $12 million to $450 to $12. I mean, that's radical within 2.5 weeks. And similar things are happening today. So training models is becoming cheaper, but we keep spending a lot more on data centers for sovereignty, go figure. But inference costs, right, which is when you input a token into a model, right, where you prompt in and you prompt out, that's measured cost per million tokens, that's gone down 100%. I should update these graphs, but these trends exponentially continue. So, yes, please.
But the real costs are not taken into account in providing all the different things of data centers. And so it's all, it's cheaper now to get all the tokens and do all the different LLMs now because it's subsidized by these companies.
I think that's factually true. Yeah, I think so. But I think also we don't have the underlying, nobody knows except these companies themselves, because they're probably spending hundreds of millions on labor and acquiring talent, right, as well. They're probably spending hundreds of millions on branding, marketing to get the upscale of the usage. Spending hundreds of millions with relationship building with regulators, spending hundreds of millions on many other such aspects, right, which are not accounted for here. Some of this is partially guesswork, but I think you're absolutely right, right? A lot of this is just being subsidized by big tech. Yes, Steve.
Cost of storage,
Yes,
telecommunication, data,
yes.
all have a, things all have gone down dramatically.
Yeah, same with the call dollars for like per call telecommunication. Absolutely. Yes.
All the basic features happened is probably faster here, but if you take in late 1990s, early 2000, that's why so many companies went bankrupt.
Absolutely. But here's a question back to you to think, right, about if you had a monopoly of a, I don't know, telecom provider or oil and gas company, or let's say a physical oil reserve, that's one thing. But if you control how people think and cognitive aspects and information, that's a fundamentally different thing, right? I think that's what we're kind of getting at here, right? Fundamentally different from, yeah.
When he wrote Republic.com, 2001, he predicted death of democracy.
Which already has happened.
Yeah, right. And I used in a lot of my research, whether they all got rejected. But you see what happens, right?
Yeah.
That's where I was talking about, the AI people will code this principle. And when it can take off. So then you have nation states fighting over these things. We saw that in little bit that happened in Indian election, Bangladesh.
Yeah.
Stuff showing communal violence. Somebody said something, and then a boom went.
Yeah.
Racial violence. Oh, that's crazy.
It's funny, the smartest people in the world, people I admire tremendously, from Joe Stiglitz to Stuart Russell, are all highly cynical about the future of these things. So what social media ended up doing, which is more polarization and thought, opinion, political views, income, wealth inequality, and more, AI is just going to accelerate that divergence, which doesn't sound terribly far from the truth.
One thing I might mention about the cost aspect
Yes.
is that most of what you're really graphing there is information capabilities. The AI, for example, it's really a vast information processor. What you don't find is the cost declining for things like haircutting.
Right.
The personal services.
Those inflation's up and up all around the world, actually. Right, prices are up.
Yeah, I mean those things are just as difficult as they ever were. It's not getting easier because of technology, except maybe there are some haircutters in Asia where they put something over your head
right.
and it does it automatically.
In Dubai, I think, and other places, yes. But to your point, right? I mean, I think you're talking also about information asymmetry, right? And a part of efficiency and productivity gain would be you will see a reduction in information asymmetry, right? But in a sense, AI is just, it's processing information that already exists. One could argue it's not creating new information. Yes, you're creating new generated synthetic content, but are you really creating new information?
Totally agree with you. That's a flaw of AI. AI, the way it's currently used with large language models today. Yeah.
That raises questions on how we think about productivity, how we think about some of these topics. And look out for a new paper by Roland and me on what we call cognitive capital and AI. Who benefits from AI? How fast? Yes.
What if I put a game theory model?
Sorry. Oh, yes, of course. This thing? I just bring the whole thing? Oh, perfect.
You just toss it to somebody.
I don't want to.
Oh, that's amazing.
Oh, wow. That's pretty cool. No, I was just thinking if you
Yes.
put game theory into it, into the AI,
Yes, sir.
where your actions and I action use game theoretic approach to counter what you do, right? Which is supposed to be based on human behavior.
Right.
So we can always build lots of these things into AI, which I believe people are working on that. By the way, this used to be an academic research in 1990s, right? And then it died very fast, but it's coming back again.
Yeah, it's back to a lot of the things that we didn't.
Beyond language model, right? That was what I think Prabhudev was also saying, because I think now, few months back, the California court ruling
Yes.
on the books, right, was based on the fact that these models are, the LLM output is viewed as transformative, not duplicative, right? So in other sense, it's being trained to transform what it learns to produce new knowledge, new information, right? That was what the courts ruled, right? Which is why it made training on these books. And then if you look at some of how the modern architectures are designed with reasoning in mind,
Mhm.
the architectures are being built so that it can produce new knowledge because it's being built with reasoning capabilities, right? So I think we've seen this transition away from LLMs. So these are now LTMs. They've become large thinking models because of the way they've been architected.
Well, actually, one of the takeaways from this is actually also the future very much lies in small language models, very much so, right? More domain-specific, vertical things rather than just bulky, heavy, large language models. But totally with you, right? Also, in some regards, I think it's going back. Agents have been around for a few decades as concepts, from expert systems to others. So not particularly new. But there are new things happening with language models too, I think, at the same time, right? It's more the scale of compute, the scale of data consumption. Transformers are not old. Generative technologies are relatively new as well. Any comments, thoughts?
It's just that I think the term, we are at a point where the term language models is no longer a good description for what these are doing. These are doing much more than LLMs.
Yeah.
Well,
That's why the LTM is taking off slowly.
The large
Yes.
thinking model,
The-
I think.
Well, I think it's debatable about the actual nature of reasoning and thinking, because a lot of that can equally be, because they are still black boxes, and we don't really like how we would do with statistical machine learning and probabilistic, ML, right, classically, to decompose, right, explainability, Shep values and other such things. I mean, you could do that. I just wonder why the big AI companies aren't doing that. And I think that's more of a UI UX kind of a question to push to the user cognitively, that these are the things my model does not know. And actually, I'll show you what I've done exactly on that. So I still find if it's thinking, reasoning, why can't I get exposure, right, to it, about how did it come up to those conclusions?
But I think your main point here seems to be that scale isn't going to get us there. That using the same algorithms at greater scale, that was how we got great progress for a while.
Yeah.
But what you're suggesting is that we need to get less general and more specific.
Yeah, I think a lot of things possibly have to do with small language models, thinking, reasoning, advancements, new architectures than just transformers, and domain curated data and verticalized stack to solve very domain specific challenges. Some ideas where the short term might be headed, but probably with the advent of more.
I also have questions.
Yes.
I know you, I mean, you mentioned that these
Go ahead and
AI
pick it up and talk into
Yeah,
it.
I know you mentioned that these AI models are using already existing information and need to be tweaked by, I mean, humans and by us. And however, it's also still evolving. Does it still seem to have the capability to, I guess the word that I'm trying to use is innovate in any sort of way, because it seems to be using already existing information, but can it really create any of its own?
Yeah.
Yeah.
I think the best evidence for a lot of that is in scientific discovery, right? Protein folding to cancer detection, genomics, studies, material science innovation. I think in actual scientific discovery. Again, I think what you will notice is those are also end up being LLM based, but there is a hybrid of many other kinds of model architecture in those cases. But I think that's where at least what we have evidence, I think, is definitely in hardcore scientific discovery today, in real innovation.
Yeah, I understand. Thank you.
Yeah, thank you.
Of course, there's also work with trying to create art with it,
Yeah.
music and that sort of thing. But the problem is they run into what Mingwei Huang and I call the average trap. So after a while, it all sounds generic.
Yeah.
But God knows in a couple of months, right? I mean, yeah, you take Paul McCartney's voice and Paul McCartney's like, yeah, it sounds like me, but it missed the nuances. But he was like, probably in a couple of months, it'll catch the nuance and drifts in how I talk. Possibly.
Yeah,
Possibly,
I mean,
right.
I guess that's why I mentioned it's because it's constantly evolving. I was wondering whether it will get to a point where it can get towards a point where there's innovation and it's not all becoming, it's not remaining general, and it's even, I guess, in art other than also like science and like tech fields as well. Like, I mean, because it's used everywhere. So, I mean,
The question actually is
oh goodness gracious.
inventing versus discovery. Right?
Yes.
Discovery is that knowledge was there somewhere.
Yes.
Human beings couldn't find it, so they discovered it. Inventing is entirely new. It didn't exist.
Yeah.
So the humans will be in that inventing side.
Yeah.
AI is going to take over the discovery.
Yeah, I guess that's the question that I was asking. I was wondering whether it can invent, whether it can innovate, and not just like discover information that's there and it just hasn't been discovered or put into words.
And this is when physical AI becomes a reality and actually does do construction on site to actually inventing new things. I think it augments the roles of humans, because I think from the current stage of things, it's pretty clear the value of human-centric values, right, and human judgment. And your domain knowledge is more important actually, because the question you ask is more important than the answer. Right. So it's like, for example, one case being the art of prompting, right? For example, and I'll show you more concrete examples on that. So from the current state of affairs, human values become more and more important, but God knows the future, because quantum computing comes into the picture in the next few years, and the computing challenge is completely resolved, and there are new model architectures. To your question of invention, right, versus innovation, right? Things will change. And it's likely, it's not unlikely. At least what we know, right? And what's happened is exactly that computing power required for the top performing models has been growing more than exponentially post 2012. We'd actually highlighted this in 2018, 2019, but this trend continues, right? So you have the top performing models from AlphaZero, GPT-4 to various others, and how you measure computing capacity, training compute flops, floating point operations per second. And you see the top models across disciplines, right, have been growing faster than Moore's law. And on the right, what you see here is performance of a variety of different tasks, all of them beating human sort of baseline. Now, there's a caveat here, right? Because one, if you put the same math and SAT exams into your training data, of course, it's going to perform and outperform humans. So people are beating the system to outperform on human baseline benchmarks. And two, things like common sense reasoning and stuff of that nature, I think it's still areas that need improvement. So again, take this with a grain of salt, but yes, you will increasingly see that variety of these models, from image classification to PhD level science questions and reading comprehension, we are performing pretty, beating human expectations. But the other point is also that the moat with AI isn't there anymore. The competition is so stiff that whatever OpenClaw or OpenAI or Anthropic or Grok comes out with last week, every other company has access to the same capabilities within a week. Right? So what you see on the left here, right, is that the difference in the top performing models used to be around 5% in 2023. That's dropped down significantly to less than 0.7%. So the AI landscape is highly competitive. And the success of what happened with GPT, where to be studied, what took Netflix 11 years to get to 100 million users, got to in 2 months. So again, these are converging trends in what's happening in competition. And the third fact is, we'll build on this further, AI is not one thing, right? We had this Brookings article a couple of month or two ago where we looked at 20,000 different tasks, subtasks of AI that's available and segmented them into different categories. And you know, AI is a highly diverse field, right? From medical, music, playing games, reasoning, robotics, time series, and more, computer vision being most active. So there's a myth of a monolith. We talk about AI like it's one thing, but it's not. So keep this fact in mind, because we're going to come back to build up a more interesting story in a moment. But I like to always say, bring back to colleague and friend I really admire, Ray Perot, who we had created the AI Index with at Stanford. I always say that AI is a data-driven field, but data about AI systems still remain hard to come by. So what is an AI system? Let me ask you. And any of the people at in the Zoom can also feel free to chime in. What is an AI system?
EU had a very specific definition of input, processing, output, like much more general than generative AI. And by that token, it's very, very broad. Like any transformation of inputs to outputs, the way like within the EU system as they were trying to regulate it.
This is why you should not have policymakers making a regulation about AI and yes. You talk about the EU AI Act, right?
Yes.
Yeah. The way I think about it, right, is that there are subsystems and components, right? And to the earlier question of Dean, right, like about failure and like better understanding that, the way at least I think about it is like this has like, because an AI system is one, AI is of many different types, but an AI system itself has many subsystems and components, right? So there's a multitude of things going on. So subsystems will include at least the data ecosystem, the model ecosystem, compute, and most importantly, the human. And I'll explain to you what this means. So at a very high level, this is a paper we had done with actually colleagues here at University of Maryland. At a very high level, right? If you were to look at the system, there are subsystems highlighted here, data, model, code, and software, enveloped in the computing infrastructure. And then there are humans involved in the life cycle to produce AI, developers, deployers, DevOps, and end users who are interacting with it. So to look at the whole system, you've got to look at some sort of abstraction like this, whereas this inside is a technical system. So if you were to blow this up and now look from the subsystems to components, you end up with something a little bit like this is an abstraction, but it's a deeper taxonomy that we had built of modalities of failure of AI system at a very component level, right? So there could be failures in data storage for data side to microservice and API downtime, so on and so forth. So this is, I think, work we're still extending, and a lot of interest in AI safety and reliability to incorporate what I had studied at Maryland, right? Which is basically reliability engineering, that we do this in nuclear power plants to mechanical systems, but really applying it with the domain knowledge to what an AI system, subsystem, component level failure. So I think there's a lot of room to collaborate on work we're extending here, but I wanted to quickly share that with you. And again, this all comes back for a lot of work that came from Maryland right here, Go Terps, because one thing very well known, 101 of reliability engineering is what we call the bathtub curve, right? So like everything in life and every system, you at the early stages have a declining failure rate. In the middle of life, you have constant failure. And towards the end of life, you have wear out, right? So you have this bathtub shape. So AI systems, and we used real data in this paper from, there's incident.io reporting from OpenAI, Anthropic, Grok, GCP, AWS, Databricks, Snowflake, like all of these systems, right? So we can measure this, and what we showed, excuse me, was that it follows the similar trend. So reliability engineering is used in our framework more pre-deployment, because you want to fix stuff from the get-go when you're designing systems. But if a system is out there in the wild, then you're using what's here on the right, a resilience engineering. And the system can go down, but like AI systems, they can then outperform where they started, right, initially. But that's like starting a completely new system. It's not the same system. So again, this very tried and tested mathematical basis for studying systems. I just don't know why we still aren't applying this at a scalable approach to safety and reliability in AI. And I'd, again, welcome having separate discussions to see how we can extend this line of work more broadly. So cognitive infrastructure, or cognitive capital, as a paper we have recently coming out, in my mind, is more about expertise, data pipelines, institutional memory that you have inside your organization, and how you operationalize AI has a lot more to do with some of these other facets about institutional memory, data, expertise, human judgment, rather than AI system alone. So something we just came out with, this is a Nature paper we had released a couple of years ago, and we just came out with a new short article at Brookings just yesterday, which basically makes a case along what I'm going to share with you. And I, again, welcome your collaboration ideas, how we can extend this work together. Where everyone in the world is asking about, hey, what's my country's AI strategy to what my company's AI strategy? And there's this whole notion of AI sovereignty stack, right, that everyone's talking about. We're like, AI for the sake of AI, it sounds pretty pointless. It's got to be grounded in real world things that you're actually doing. So we have deep sort of data and empirical work, but the idea is very simple, and it can be applied at a company level or a country level. So I'll just give you one very simple example, right? Build on your existing strengths in goods, services, and AI capabilities you have. Relate a multitude of AI into specific. So if you're Bangladesh, as an example, and you do garments, okay? Maybe computer vision, and certain type of computer vision is very related to garment manufacturing. You apply it in quality assurance for manufacturing of garments to improve reliability, quality of delivering garments at a factory. Now that you have connected this particular type of AI to the garment industry, learning from the network of the world, you can see in 2 to 5 years, people who connected these two things can go into boilers or shipbuilding or other things. So it's more what AI helps you make your existing economic strength more competitive, and two, what possibilities does it create for you to diversify in the future? So, yes, sir.
Can I ask you a question? Just push back on that argument.
Yeah, please.
The economic characteristics are not static.
Of course.
Right. So all these things are still in such early evolution. We can't make any prediction what happens 3, 4, 5 years from now, right?
I'm not saying we do that. I'm saying we look back the last 20, 30 years to see what has happened, actually, to inform at least a trajectory of how you may wish to. First is, what kind of AI should you connect to what strengths you have? You cannot argue that you can't just be doing AI for the sake of AI.
Which I agree with you.
And it has to be grounded in real world goods, services. We're forgetting about University of Maryland is very good in the business school and in engineering program. That's an economic strength, right? We have amazing faculty. There are certain strengths we have. So it has to first and foremost make our existing strengths more competitive. I don't think you can argue with that, would you?
It's a capital labor substitution problem. So you brought the example of Bangladesh.
Yes.
Right. So it's about AI systems are not cheap. It's extremely expensive. And here we have states where they won't let Walmart come in, even today, in this country.
Let me push back to say, like, why are AI systems expensive? Because now all the things we're talking about, accessing AI models from Africa to Latin America of different types, is cheaper than it ever was.
Yeah.
I mean, I'm not talking about building your own training model and computer infrastructure, but accessing.
Accessing is different from
building your own stuff. And that's my point for AI sovereignty talks. Everyone's talking about, I need the whole compute infrastructure. I need to have like data. I need to import labor. What I'm telling to those AI sovereignty folks, you're missing the picture because you're just forgetting about economic sectors and strengths. That's the first point for, back in the days, we used to have something called industrial strategies in countries. And, now we have like AI blueprints in every country now has some
they're all
very cheesy and yes, like, it doesn't really have, it's like the EU Act, which again, that's debatable. I think there's some good things there. But now I think what I'm really talking about is that mixture of industrial strategy with data-driven AI blueprints for countries or companies. That's all I'm talking about. Yes, sir.
I can concede. I concede how companies themselves can go about building their own systems. I'm all for that, the individual too. But I think it would be a mistake for an entire country to go in on this strategy for a couple of reasons. First, can we agree that AI systems are hard to build natively? Just you're not using someone else's, you're building your own thing. That's pretty expensive. Can we agree on this?
Agreed. So
that means your method of building an AI system as a country would be to use large language models or any of the other soft things that you've just said on the screen. But by doing that, you're introducing a lot of safety issues. That's the first kind of track. A lot of safety issues that you have to mitigate. Other countries being able to access your data. Now, that can be its own topic of conversation. I just want to put that track there. The other side I see is when AI systems, it does become feasible to create your own system, there's a kind of path dependence that countries are going to be on, that they can't switch to these new models that they can build themselves and build for their own economy. And you're also having to navigate the safety issues that come with switching in the first place. And you have to consider the leverage that these companies will have over these countries if they should switch. You see what I'm trying to say? So I think it's an issue of if entire countries start adopting this model, but local like companies or the individual, like this is the best case use of AI at the moment.
What's your name, sir?
Shri.
Shri.
Yeah.
I was just at the 2 weeks ago or so, 3 weeks ago, like I was at the AI Impact Summit in India. Traffic was horrendous, by the way. I had moderating a panel, I couldn't even enter. And then I had to be like, if I don't enter, I'm not moderating this panel, sir. The reason I'm saying that the AI Impact Summit, I think very much also addressed a lot of these things, and India came out with their own multilingual Sarvam and a handful of other models, domestic to India, small language models, and many new things. I'm not at all arguing from a national security point of view that I think that you're getting at, right? That you need cloud sovereignty. You don't want to be dependent. Hey, if in Dubai and Iran, the AWS data center is being attacked, you need to have backups. And, if your country is relying on other countries, sure, that's an issue, right? If you're not building your own data ecosystem and you're not finding a way to import the talent or not building small or large or any kinds of models inside your country, sure. And I think that's a debate. How much do you import versus build internally? There is a space for all of that. I'm not arguing from that. That's each country's national security priority. What I'm talking about is that these strategies should be grounded in the reality of the myriad of strengths that exist in your country. It's not AI for the sake of AI. Just like we need to build our own AI stack. But for what? I make microphones in my country. I make bottled water, right? I make oil and gas. I do architecture engineering services. I make clothes, IT systems. That's what we've been doing for 20, 30 years. We are the number one in this. Now, what type of AI helps that what I do very well relative to the rest of the world be more competitive? That's the more important question I think that we're missing with the current debate that we have, right, about AI sovereignty and national security. We're missing what are we really good at and how does that help? What type of AI helps us be more competitive? How would you think?
Yeah, I see that point, and I agree. I would go further almost and say it's not just improving your strengths, but it's also mitigating your failures. That's the two ways to improve. You either get better at what you are already good at, or you get better at the things that you're not good at, right?
Totally.
But I guess the next kind of point I had, this is more of an internal reflection, and I want to hear your thoughts on this. It goes kind of against what you just said about making AI for the sake of AI. Now, it's crazy that I'm trying to dismantle that point, but my argument goes like this. AI is in its infancy stage. It is still relative to, let's say, 20 years from now, what AI is going to look like.
Of course.
So why not give AI the runway it needs to take off? Why not make AI for the sake of AI to see what is working, what isn't working, and then we can start a discussion about maybe the best way to go about doing that. It's like how you learn, how a child learns. They have to fail. They have to kick the ball around. They have to be on the playground. But eventually they know that they have to come to an event like this and they have to expand their mind. Even right now, I would think I'm saying, I don't know like half the things you're talking about, but I'm still here. I'm still trying to fail. And I think that same mindset has to be applied with AI because it's not AI that's being built. It's humans building AI. I think that's another important distinction to make. It's not AI building AI. It's humans building AI. So we need to give humans the space to fail and thereby AI the runway it needs to eventually grow into something.
I love that perspective. I think that's fantastic.
Okay.
I completely agree with you. The only completely maybe non-related comment I might have to that, are you going to trust the people and their values to build super powerful systems that, like the Dean and Balakrishna you were talking about, just can go rogue? And not saying existentialist risk, but like could really make things go really crazy and bad. Like, how would you think about human values, right? Of people just like, let's go build anything. And because these things are becoming super powerful, maybe superhuman already, not at all like how the human brain, but it's in all regard, to have complete free reign to see, it's an open philosophical question. I'm not saying that.
Yeah.
But like how just to
It's hard
counter.
because
Yeah.
you're almost having to weight human creativity and the ability to innovate to begin with against regulation. And I think this is, well, just the balance that civilization has been trying to find an answer to. But I guess just in our current system, it's not possible if we're thinking about like the industrial revolutions for a second. I mean, many jobs got cut when you started transitioning into this new state. It's just what happens. Now, that's the unfortunate truth of it, but to somehow limit creativity in the sake of preventing failure, I mean, you have to expand out for a second. Is the single human more valuable than the development of and the benefit of all human beings as a result of the revolution? I think that's like an important question to ask. And in my opinion, I would still have the industrial revolutions happening the way that it is because it does allow for growth. Now, it's unfortunate that some people have to face the negative consequences, myself included, but that's the way it is.
And we noticed that he's not very far through his talk. And so what we would like to do is let's give him 10 minutes just to speak, and then we'll go to Q&A.
Sounds good.
I love your perspective and keep going. I don't have a question answer right on that, but I think that's great. You're thinking about these topics, and the question is more important than the answer, my friend. So that's exactly right. I'm just conclude this section. I'll just give me like 10 minutes and we can spend the rest of the time talking together about these things. But here's a concrete example of what I was talking about, right? RCA means revealed comparative advantage. We looked at data in physical goods, the country of India in this case, services, and AI investments. So surprisingly, India's private AI investment, VC investment in restaurant, food and beverages, robotic automation has a lot of capabilities, but also in precious stones, ships, manufacturing services, and ICT. So first part of this framework, right, is like stop taking what am I really good at? And we can extrapolate by looking at the global network to the Dean's point to see that what did countries do, looking at the last 20 years or so, to extrapolate what happened. So if you zoomed in to blue is a AI investment category, and the purples are service and goods. So what we see as evidence that if you invest in robotic automation related AI, in subsequent years, countries develop competitive advantage in shipbuilding, maintenance services, chemicals, machinery, and so forth. This is all my point, right? A data-driven way to help your existing economic strengths. But in interest of time, let me kind of conclude this section. To all the topics we're talking about, yes, if the first service revolution, if you remember, I was talking about that, right? Sure, if call centers and back office services, right, took off in Philippines and India, and in fact, AI can do the job cheaper, better, and faster, it opens up questions like, yeah, what are those countries going to do? And at the end of the day, what really comes down to, right, is I think how we think about comparative advantage and human values. So we'll come to this, but what I want to shift gears a little bit, right, is to talk about all of these things now, but from a perspective of the largest industry on the planet and most consequential and sort of work I've developed with my company over the last few years. And really the impetus for a lot of this work, I'll share a QR code and referral code so students can leverage it for respective. I'll share this in a second, so don't you need to take this. But also for I think faculty and postdocs, massive amounts of data for novel new research. So, God, 5-10 minutes. So let me kind of get to run the show here. So very quickly, so this is what I'm going to share with you is not got anything to do with your general Anthropic and GPT and Grok, because what I'm going to share with you is behind the scenes, we've assembled the entire construction, infrastructure, procurement, and risk data around the world to build a vertical AI solution for this massive consequential industry. And that makes a world of a difference. So I want to explain what that really means. You can don't take my word for it, but look at our clients. But I think I like the quote in the middle because constantly people would like put in the same prompt into Construct Chat, which I'll share with you momentarily, and put it into 4 other chatbots and ask the third chatbot for this industry at least, right? Which response was more comprehensive and reliable? Happy to say unanimously it says it is Construct Chat and Tayo. So it's really about domain knowledge and this cognitive infrastructure aspect. So why am I talking about this? One, the motivation is really the fact that productivity has been declining in the construction industry for more than the last half century relative to other industries. Margins are significantly lower for publicly traded construction companies versus S&P 500. The real root cause, right, of all of this is where's my slide? Okay, I'm going to come to that in a second. Root cause is the data deficit, but I want to quickly paint a picture of how consequential this is, because mega projects, which are billion-dollar plus projects, many of them never get started. They're well known to have cost overrun. You say California high-speed rail is going to be $2 billion. 25 years later, it's actually 15 billion, and it's still not started being built. And it's also consequential in the sense of the biggest impact on climate change, right? It's from CO2 emissions, material waste, resource extraction, pollution of all sorts of things. I want to give a very quick story. Very early days as I was building this, I was talking to one of the governments in India, and I asked the central government, this is before AI became such a hard thing, that how could AI help solve a problem for you? And Agra is a city where the Taj Mahal exists, if you know. And he said, like, can AI help me call out BS to the central government that the mayor of Agra is actually trying to build a mass transit system. He just hired KPMG to write a concept note to make a case, and the central government's going to approve it. I need to make a case that it makes no sense for a city like Agra to have a mass transit system. It's already had congestion problems. If you build a mass transit system, things are just going to be bad. So, like, how can you do that? I couldn't answer that question to help him at that time, but I'm glad to say we can. So, infrastructure matters, but it's growing faster than ever before. It's like AI; it's growing much faster. So, it's outpacing the world's GDP to population growth from everything from shipping, fiber optic cables, high-speed trains, data center power, and more. This just keeps going. So we can't just build and build. We got to build more intelligently. So here's a little joke for you guys, important reality. So something actually I'd learned at one of the classes in University of Maryland, and I stole this. So I like this because this is an example of a project that was proposed by the project sponsor. This is the same project as it was in the project request. The same project as designed by the engineer. Same project as produced by the manufacturer. This is how it was installed at the user's site. But in reality, all the user wanted was this. So information asymmetry, but also different perspectives. These massive projects require governments, construction companies, design engineering firms, infra investors, and more. So I think aligning people, right, on the same values and on focus is an important aspect of solving that problem. So what happens is these projects, and same thing with AI, projects are mega projects, 5, 10, 15 years to build some of these systems. So the cost of these projects is going up over time, but the control you have over them is going down. So we end up spending significantly less than 5% of the budgets, but it ends up costing more than 80% of the life cycle cost, as well as climate change related aspects. So the point is, the decisions you make at the earliest stages make a world of a difference. And this is sort of where I ended up focusing my PhD, but also my current work on the business side. So the problem really is to build agentic and intelligence systems, you need data. And data for this massive industry is really hard, right? Because it's a complex challenge where infrastructure construction transcends regulatory jurisdictions, right? Cities, counties, state government, federal government, multilaterals, as hundreds of thousands of government agencies. It's also very complex because there are many different sectors. So anything from digital, renewable, non-renewable energy, different kinds of transport, defense, social infrastructure, water, agriculture, and more. I think in the US alone, there's 15,000 water agencies. So while governments are publishing a lot of this information, there isn't one place where all the future planned activity and what's happened over the last half century sits in one place. I don't want to beat a dead horse, but I think the challenge really, this is a very complex thing. So what I'm going to share with you is this kind of Bloomberg-like interface, and then there's Construct Chat. You see on the right, you have a lot of prompts that are emerging here, which gives you a sense of the variety of use cases that can uniquely be addressed. Right? So anything from permitting delays due to NEPA in the US to due diligence or doing deep project research. You want to ask deep questions about sourcing suppliers in Africa or the Middle East, labor market risks, to asking anything. Is there a problem?
Oh, no, it's just in the interest of time, we probably want to leave a little bit of time for Q&A.
Let's do that.
So maybe wrap up in 30 seconds, and then we'll
30 seconds.
Then we'll move over to in front of the sign.
Let's do that. Well, I'm not going to get in depth into why this is different and what we really build, but I won't have a chance for really a demo either. So let me skip all this, and I'll invite you all. One of the things actually we've been doing is there's an open source element of this where we have a prompt library and universities, associations, and industry players all coming together. So I won't have a chance to go into the demo, but I encourage you to try it yourself. So let me just give you two last things. One, this slide you can take a screenshot of. I welcome the wider University of Maryland community to partake in this. So you just go to that link, use that referral code, try it for yourself, and I'll share this with Roland. So all faculty, students, and others can leverage this to your own advantage. And we're building case studies for immersive learning. That could be another aspect. And 20 seconds, and I'll close here. 3 areas, I think, of collaboration opportunity. One is for faculty, postdocs doing research. There's a lot of underlying data here. So use us to build innovative new research that wasn't possible before. We're building a lot of very interesting immersive learning case studies to inform not just the infrastructure construction industry, but broader supply chain and government contracting. And I think there's a lot of many interesting avenues of helping governments and private sector executive education to be more resilient. So let me stop there. Thank you for your time, and we can chat more.
Thank you very much. Well, I think you can see that he's a true visionary. He's really created an industry that didn't exist. Well, why don't we go over here and take any questions that people have?
Yeah, can I ask you a question about? Oh, you're asking.
Yeah, go ahead and ask.
Why do you call it cognitive?
for my own why talking. Another one is when rules regulations continue to evolve, and it is evolving very fast, globally, especially in construction.
Yes.
How does the system evolve to be more intelligent?
Yeah, and cognitive infrastructure. I mean, there's a new paper actually we're coming out with where labor productivity for the longest time has been thought about as physical capital and labor. But we think what's really a missing element is how human cognitive capabilities, right? And how AI actually impacts how we work in the world. I mean, was really the advent of the cognitive capital initially as a term, the value of human expertise. And as we're looking at our industry in construction infrastructure, we call it physical infrastructure. But what's really missing is the cognitive infrastructure to build more intelligently for the future. So really the intelligence to build. So a lot of these facets actually ended up like creating the concept of cognitive capital, which you'll see a paper on that, and what we've been calling cognitive infrastructure, which is more the underlying basis to operationalize AI.
Can I explain
Please.
how I understand it? 'Cause
Yes, absolutely.
I think this is a brilliant concept. And I really think very highly of it. How I understand it is, typically we've had labor and we've had capital. And the labor basically does what it does in sort of a routine way. That's been the old economy. But these days, there's so much that's information oriented. And we don't just keep that information in people's heads. We actually build an infrastructure that contains that information, that basically maintains the culture of the company. Is that accurate?
Yes, absolutely. Did your second part of your question was?
No, these models that you build based on past data, a lot of them are based on the current rules and regulations that existed, right? Especially in construction, a lot of changes are happening today, especially in commercial side of it.
Yes.
Rules, regulations are changing. So how does this, any insight you get can be used for the future? That's my question.
I'll answer that question. And mind you, like in this industry, right, people, you can't rely on hallucination, right? I mean, that's detrimental. You want factual, real things, right? So one of the things, the system is actually real time, learning from what's happening in terms of regulations, policy nuances, and underlying is granular, grounded data, not just about the past, present, but up to 20 years or maybe more sometimes, of what might be planned and coming down, governments might be thinking about and planning. So there is that kind of futuristic data. There's also, I didn't get a chance to show you the power, but whether it be aggregating NASA, NOAA, Google Earth engine, and other spatial aspects to look at reliable foresights and forecasts of sea level rise and things of that nature as well. So there's a lot of grounded future data, but then if it does not have the data about the future, it's inferring based on grounded data. So it is.
That's why it's cognitive.
Because planning intelligently for the future, definitely, yes.
You haven't asked any question.
See, we're not having enough fun with that thing. We should be throwing it to people.
Just don't hit someone in the head.
You guys have?
Go ahead, you had a question.
Okay, hi, Professor, Dr. Mishra and Roland, thank you for the talk. It's brilliant. And my name is Ling, and I'm a 5th-year PhD student in marketing department on the quant side. So I'm actually working on something like very related to what we're talking about today. So what I'm doing is that basically those like consulting firm all have their like previous information, their code and knowledge, like what you call like the grounded truth that has been working, that they know that works, that is their strength.
Yes.
And when like in a specific application, when the consulting firm, they work on a project, they have all these developed models and all the reports and the so on and so forth. And when the employee, they left the company, those knowledge just fade away, just left with the employee, because they,
Totally.
yeah, like what you have mentioned, that's their analytical strength, but they don't have a way to preserve that without, but with large language models, there's a way to do that. What I have like developed is a system like similarly to put all this strength into a knowledge base and connect it with a large language model using RAG, and automate the feature engineering process and the like evaluation model training using the automated machine learning, and which we prove that it facilitates the accuracy, prediction accuracy for the downstream marketing applications like demand forecasting. You've been talking about also, and also it reduced the operation time greatly from
So are you
days to hours.
interviewing people about to retire and leaving the organization? How do you encode the knowledge base of the people about to leave the organization?
So do you mean that we did like survey with all the people, like the engineers from the company, and see whether they are you actually using all this knowledge, or they like using some ways to using the knowledge in the previous projects. And the fact that we found that is all these engineers, they all have access to the prior knowledge in the projects, so on and so forth. But even with that access, they cannot performance as well as the large language models.
Interesting. You know, is it only for consulting companies you're doing this, or more broader for organizational learning, so to say?
So we position it to be the organizational memory in a broader sense, but the data we are getting from is from a specific multinational consulting firm.
Got
And
it.
we we experimented on 4 different large language models, both open source and proprietary, and we have seen like our system outperformed human benchmark, and also performs better than some end-to-end models like the foundation model for time series and the time GPT models. So that's what we found, which I think it's like the broad idea is very, very much relevant to your talk today.
I love it, and I'd love to chat with you more in depth. We can talk more offline, which was a multinational, consulting company, and you should sell it to all of them and create a bidding war for your work. But you know what's an interesting facet in the construction infrastructure industry is that unlike all this talk about job losses and AI, that's a hot topic today, 41% of the workforce in the construction industry will retire in the next 4 to 5 years, right? So it's a intergenerational knowledge transfer challenge, right? So it's not about AI and job losses. It's more like this industry desperately needs something, right, to retain the knowledge that you're talking about, right? And it's kind of it's an existentialist risk, because a lot of these deals and business was done on human networks and tacit knowledge inside the brains of people. And if they retire, they take those networks with them. So how does data and AI help address that challenge? I think it's a very important challenge, right? In especially the context of this industry. The question, yes, sir.
Oh yeah, throw the thing over.
Throw it. Don't hit his head.
I had a question. Oh, a little bit loud. But my question was more on your point where you're talking about the construction industry and about how 40% of them are going to retire.
Yeah.
Well, mine is not towards construction, but in accounting, right?
Yeah.
Over, I believe 60% of CPAs are over the age of 60, right? Like in the accounting world now, they're trying to like make it easier for people to get licenses or to but the process is still hard where you have to do the whole test and all that. do you ever see a scenario where they're gonna start implementing AI to make up that loss of that significant loss of CPAs in the accounting industry, sort of like for the construction industry?
Yeah, we'll talk on that.
Yeah, my thinking is, yeah, it's amazing there still are accountants at all. I mean, I think AI is going to take that over.
And like it actually begs the question of which industries, right, cognitive capabilities, right, would be more easily, especially again, certain professional
Well,
services.
especially, I mean, accounting is so rule-based that it's a natural for AI.
But I think it's also a very nuanced question, right? Because automatically one would think that translators, I mean, of course, I think the cost we saw for what language models can do versus Google Translate, that reduced by 350% in the last year or so, right? So language models can do a bunch of different things other companies can do. They're putting startups even out of business, whole industries, so they say. And one of the top things that comes to mind when you're saying that, Roland, is that it's a no-brainer. Translators, heck yeah, that should. But interestingly, if you look at the latest month-on-month stats in the short run over the last few months, the job for translators in the US has actually gone up. So again, it's not a long-term or mid-term foresight of that might still happen, but at least we haven't seen that in the data yet.
Well, certainly the data rules for you, that's for sure.
Well, but I'm not saying
No, I mean, you're the data guy. I mean, you know more about the data than anybody in the world, probably.
Well, I don't know.
No, it's really true. I'm not making that up.
That's too kind.
Maybe we have time for one or two more questions, and then I think we should probably finish up. Anybody have a question?
I mean, I have a follow-up question.
Okay.
So if that's the case, for students coming out of college, right, or that are in college right now, what would you recommend for them to really put an emphasis on, in terms of, okay, this is where you should really focus your studies towards, or skills that you should grow coming into the real working world? I don't know. Yeah, based on your research.
I'm going to jump in for that one.
Yeah.
Because Minghui Huang is going to be at the business school on March the 30th. Is going to be talking about exactly that, and that'll be one of the things that come up in that talk, and we have some strong opinions about it. I'll give you just a quick look of ahead of time. We believe that it's the feeling tasks that are going to be lasting longest. And that means if with AI taking over more thinking tasks, people get pushed into the feeling tasks. And of course, eventually AI is going to take over the feeling tasks as well. And that's going to be part of the March 30 talk as well.
I was talking to a college student the other day, and they were like, they were working in a public university, and they were I rely on AI for everything I do and my homework. And luckily, the university does not check, so I get away with it. And it was very interesting, right? I think there's to Roland's point in mechanical thinking and feeling levels of cognitive capabilities. I'll give you an example. It's impossible, if not so difficult, over the last few years, if you try to hire engineers, you see a straight up erosion in coding practices because people are just getting lazy. You see erosion of critical thinking. So as we conclude, I think what helps students and younger generation, it's how education will and how AI could help, right? To retain our critical thinking. My personal feedback is be independent, be unique, be yourself. Don't follow the herd. And I think it's really a back to human values as much as possible, because your domain knowledge, what uniquely that you have, right, and who has made you, is more important and will become even more important as we look to the future. So stay resilient to chaos and uncertainty and be yourself.
One last question. Yeah, let's give it a toss.
Nice.
Throw.
Good one.
I think good catch, but all right.
Amen.
Back to what you just said. So if what's important is going back to your values and what makes you you, that sounds great. I'm for that. But we just talked about how AIs are doing better than human beings at certain tasks. So how do we square those two mentalities? If AI is better than us, why does our experience now make that more like? I guess I want you to talk more about it. I can't quite right now get there, but I would like to hear what you have to say.
I'm sure Roland has a lot of opinions
Oh,
on that.
yeah,
Yes.
I mean, we'll talk about that
Yeah.
on March 30. Come on March 30 and you'll see the answers to those questions.
Sure.
Another way to think about it, right? Okay, let's say stupidly language models and like chatbots and stuff, right?
Mhm.
You're only as good as a question you ask it. If you're gonna ask a stupid question and that's not very well founded, right? You will get some answer, and if you're not paying attention, and if it gives you things that is not truthful and grounded and reliable, you will take it and you will go further down the chain, right? This is one narrative example. So something I mentioned earlier, right, on critical thinking, it's the question that you ask is more important than the answer. Something in education for decades we've always tried to imbibe by. So I feel that aspect, right, of knowing which question and line of reasoning, AI may or may not teach you that in today's world, might in the future. But I think so that's why your critical thinking, your human judgment, your values are extremely important for you to remain human while AI gets better, faster, and more intelligent, because it may replicate your feelings very soon, as Roland said. So be wary.
Well, thank you very much for a
Thank you.
wonderful presentation. Saurabh lives in Paris, and the fact that he could get here to talk to us is really a wonderful treat, and I think we all benefited tremendously. Thank you very much.
Roland, thank you so much. And so good to be back home on the campus. So thank you all very much. Thank you.